Okay, so we are starting today electrolysis. So electrolysis is actually a chemical reaction. It is a chemical reaction to separate metals, metal and a non-metal from an ionic compound. From an ionic compound by SCREW. REW by passing electricity through its molten or aqueous form, aqueous solution, molten or aqueous solution. Write down, then I will explain it. What is this thing?
Okay. Done.
Okay. Now, what is this thing? For example, we have got sodium chloride salt. And we know that all the ionic compounds at room temperature, they are solid. Why? Why they are solid? Because they are giant crystals. Okay. We have recently learned this, that one positive cation, one negative, then one positive, one negative. And in this way, they are arranged in a regular three-dimensional way, stretching far and wide. So they are solid at room temperature. Now, it is consisting of sodium cation and chloride anion. Now, from these two, if you want to get pure sodium metal, it's not a metal, it's a cation. And if you will get chlorine gas from this compound sodium chloride, a pure metal and a pure non-metal, you have to do the electrolysis. You have to pass electricity through it. But electricity cannot be passed to a solid compound. Why? Because in order to pass the electricity, the particles must be freely moving here and there. Here, the cations and anions are sticking up with each other, just like the pieces of magnet. So you cannot pass the electricity. You cannot pass the electricity. So what you have to do, either you have to melt it. So when you are going to melt sodium chloride, sodium cation and chloride anions will be separated. The electrostatic force of attraction between them will be broken down by heat. So that is called the molten compound. So you melt it and then you can pass electricity easily through it. Or you dissolve it in water. So when you dissolve it in water, in that case also, electrostatic forces of attraction break up and the cations and anions become free and mobile. That is called aqueous solution. So first of all, what we have to do, what is our purpose? The purpose is to get sodium metal and chlorine gas from sodium chloride salt. What is sodium chloride salt? A giant ionic crystal. And giant ionic crystals are solid at room temperature. Solids do not conduct electricity, and we have to do this experiment by passing the electricity. But the solid ionic compounds cannot conduct the electricity because the cations and anions are not free and movable. So what you have to do, either you have to melt it or you have to dissolve it in water. Melt means molten form, dissolving in water means aqueous form. then the reaction, then you will be able to pass the electricity. How it is being conducted? How it is being conducted? So we have to have a container, and that container we will take the solution. So this solution of sodium chloride salt in the molten or aqueous form is called electrolyte. So what is electrolyte? Electrolyte is a compound with free and movable cations and anions. Any such compound with free and mobile cations and anions and which is capable of conducting electricity is called an electrolyte. So you have taken electrolyte in the molten or aqueous form. In the molten or aqueous form, you have taken electrolyte. Now, you have to pass the electricity through it. So you have to have a source of electricity. So what we have to have? We have to have a battery with positive and negative terminal. So we have to have battery. Then we have to have wires connected with the battery, but you cannot just simply dip the wire in the electrolyte. So how you are going to connect the electrolyte with the wire? You have to have two poles. So this is one pole, this is another pole. So this wire is connected with this pole. So this pole will become a positive pole. And this pole is connected with the negative terminal. So this has become the negative pole. So what are these two poles called? These two poles are called electrodes. They are called electrodes. And what they are made up of? They are made up of a least reactive metal. Least reactive metal. The metals which are below hydrogen in the reactivity series. A least reactive metal like copper, silver, gold. But they are expensive and they will affect the process of electrolysis as well. So the best way is, in order to, uh, take the neutral electrodes which may not react with the electrolyte, the best choice is graphite. You can use graphite. Graphite is nothing but pure carbon, but this is the form of carbon which can conduct electricity. So if you are taking the two poles made up of graphite, they are non-metals, they will not react with the electrolyte and they will easily conduct the electricity. So when you will pass the electricity will start its journey from negative terminal to the negative pole, and then from the electrolyte into the positive pole, and then in this way the circuit will complete. On the passage of electricity, some changes will take place in the electrolyte. What changes will be taking place in the electrolyte? All the cations, the positively charged particles, will be attracted to the negative pole. And a chemical reaction will happen over there. All the cations will be attracted towards the negative pole. So cation are the positively charged particles. So negative pole will be the name given cathode. Cat. Cation will be attracted towards cathode and will chemically react over there. Similarly, all the anions, the negatively charged particles, all the anions, negatively charged particles will be attracted toward the positive pole. Will be attracted towards the positive pole. They will be attracted towards the positive pole. So the positive pole is given the name anode. Both of them are started with the word an. Anion, anode. Cation, cathode. Cation positive, cathode is negative. Anion negative, anode is positive. So what does it mean when we will pass the electricity over here? What we are going to see that near the positive pole, all the negatively charged particles will be crowded. They are attracted like this. And a chemical reaction will happen. And around the negative pole, all the positively charged particles will be like this. And the chemical reaction will happen there. Up to this much is clear. Hiba, if you want to copy something from the board, you can.
Okay, I'll copy this. Okay, done.
All right. Now see, let's start with the electrolysis of the molten compound. Examples of some electrolysis in the molten compound. So electrolysis of molten compounds are very, very easy. Electrolysis of molten compounds. Okay. So let's start number one, molten sodium chloride. Okay. So when you will melt sodium chloride, it will split up into sodium cation and chloride anion. Now, what will happen at cathode? Negative pole. Cathode is a negative pole. And what will happen at anode? Anode is a positive pole. All the cations will move at cathode. So sodium cation, they have a +1 charge. What does it mean? +1 charge means they have already lost one electron or completely given away one electron to chlorine. So they have one electron lost. They have a deficiency of one electron. As soon as they will touch cathode, they will gain one electron. So we will write 1 E minus. Electron has a minus charge. So they will gain one electron each sodium cation and will convert into sodium atom. Why? Because the deficiency is fulfilled. The number of electron and proton become equal. So they convert into sodium metal. So one by one, sodium cations will come, will touch cathode and will gain one electron and will convert into sodium metal. So after some time, we will see over cathode a grayish color layer of sodium metal will form. So we will just scratch it and preserve it as pure sodium metal. Now you can see at cathode, gain of electron is taking place. Always remember, reduction is the gain of electron. So at cathode, always reduction of cations is taking place. Clear this idea, Hiba?
Yes.
Now, what will happen at anode? All the anions will move at anode. So see, chloride -1 charge. What does it mean? They have already gained one electron. One electron is more than proton. So they will lose one electron by touching the anode and will convert into chlorine atom. Single chlorine atoms like halogens always exist in the two form, diatomic form. Single chlorine atom does not exist. So two chlorine atom combine together and will form chlorine. So from the side of the anode, you will see greenish color vapors of chlorine gas are produced. And we will, if you have understood this equation, these two equations, we will merge them into one equation. We will not write two equations. Like each chloride ion will gain one electron and will form an atom of chlorine. Two chlorine atoms combine and form chlorine gas. Instead of writing them separately, we will write this equation in one equation. How? How? See, two chloride ions, instead of writing -2 electron, they are losing -2 electron or they are losing 2 electron. Why? Because each will lose 1 electron. So 2 will lose 2 electron. So instead of writing -2 electron before the arrow, what I will do, what is the way of writing? I will take the 2 electrons minus on the other side and it will become +2 electrons. On the other side means they are losing the electron and forming a molecule of chlorine gas. Did you understand this thing?
Miss, could you explain it once again?
I will explain it again. Two chloride ions. Each will lose 1 electron, so 2 will lose 2 electrons and they will form a molecule of chlorine gas because we have to get Cl2. So we started with 2 chloride ions. But instead of writing -2 electron on before the arrow, let's write it after the arrow, so that we do not have to write -2 electron. So we have to write 2 chloride ions will lose 2 electron to make a molecule of chlorine gas. Got it?
Okay.
Do few more and then you will understand. Copy
Okay.
it. I will show you few more.
All right. Done.
Okay. Now see. So potassium bromide, when you will melt it, it will break down into potassium cation and bromide anion. So potassium cation will gain one electron and will form potassium, pure potassium. Again, two bromide ions, each will lose two electrons and will form vapors of bromine gas.
Okay.
আসলে কেউই কখনো কাউকে ভুলে যায় না, শুধু প্রয়োজন ফুরিয়ে গেলে যোগাযোগ বন্ধ করে দেয়। जरूरत खत्म होने से BASBASTOB B done.
ये जो जंग बढ़ा है ना, पूरा दुनिया पागल हो जाएगा ये जंग को रुकाने के लिए, क्योंकि इसमें तो खाली साउथ एशिया, खाली इंडिया पाकिस्तान नहीं, पूरा साउथ एशिया क्या, पूरा वर्ल्ड इसमें स्टेट है वर्ल्ड का।
Miss, I'll be back in 2 minutes.
बाप दुनिया का वाहिद शख्स है जो खुद से ज्यादा अपने बेटे को कामयाब देखना चाहता है। ये सही बात है ना कि आप अपने बेटों को खुश करवाना, ये हमने आपको वर्ष अपने ये पर
Yes, Hiba finished.
Miss, I'll be back in 2 minutes.
Are you there?
Miss, can you not hear me?
No, I was not hearing you. Now I can hear you. Shall I rub the board?
Hello?
Hello, I can hear you. Can you hear me?
Yes, I said I'll be back in 2 minutes.
Acha, okay.
Back. Hello?
Yes, I'm writing one here. You do by yourself. Molten magnesium chloride. Please do it. How you will do it? See the previous examples and do. कहाँ जा रहे हो? मैं हूँ क्या? क्लास We have less than 1 minute left, Hiba. Anytime the meeting will be over.
Yes.
Could you do it?
I'm still trying.
जाना आपको